So let us continue lecture 4. In the previous video, we saw that indexing of points is achieved by representing the coordinates of a point as a fraction of lattice parameters of that unit cell. In this figure, you can see that the lattice parameters are A, B, and C. A is the lattice parameter along x-axis, B is the lattice parameter along y-axis, C is the lattice parameter along z-axis. And as you can see in this picture, point P has coordinates QA, then RB and SC, where QA is a fraction of the edge length A. Similarly, RB is the fraction of edge length B, and SC is the fraction of length edge length C. Okay, so we know that Q, R, and S, as their fractions, their values lie between 0 and 1. Okay, so that's how we represent or locate a point, crystallographic point in an unit cell. Let us solve an example of indexing of points in this video. For the unit cell shown below, locate the point having coordinates 1, 4th, 1 and half. So those are the values of the fraction, which means that Q here, sorry, let me directly, okay. So 1/4 is the fraction of edge length along x-axis. So this is Q. 1 is the fraction of edge length along y-axis, which was R, and half is the fraction of edge length along z-axis, which is S. Okay. The edge lengths are given here in the picture. So unit cell edge length along x-axis is 0.48 nanometer. So you should be aware that nanometer is 10 raised to minus 9 meter. Edge length along y-axis or B is 0.46 nanometers. So this is B, A is 0.48, and finally the edge length along z-axis is C, 0.4 nanometer. To locate the point, we should know QA. We should calculate QA. Sorry, I will use another color for this. We should calculate QA, which will give you how much we have to travel along x-axis. Similarly, we want to find out how much we have to travel along y-axis, how much we have to travel along z-axis. So to find out how much to travel along x-axis, we will have to find out the product QA. It's not appearing properly. So Q times A. Similarly, how much to travel along y-axis is the fraction of edge length along y-axis, which is B, and then S into C. Okay. So QA, so 1/4 of A is 0.48. 0.48. Similarly, along Y, fraction R is 1, and this is 0.46. That means we have to travel the entire edge length along y-axis, and along z-axis half of C, so half of 0.4. Okay, so that's how we calculate the fraction of edge length. So the calculations are 1/4 of 0.48 comes out to be 0.12. 1 into 0.46 is 0.46, and half of 0.4 is 0. Okay, so those are the coordinates of the point that we want to locate. So let us look at the point here, and again the origin of the coordinate system lies here. So from here we have to travel 0.12 nanometer distance along x-axis. So 1/4 of that, so very small distance. So we come here, that too is large, so that is the point. Then we have to travel the entire edge length along y-axis because the fraction r is 1. So entire edge length along y-axis, oops, sorry. So we come here, and finally half along z-axis, or 0.2 along the z-axis, slightly slanted here, so half of that. So this is the point P. I will use another color to represent this point. Let me use green color. So that's how we locate point P, for example. If we call that point as P, this is how we locate point P. So this is the solution to the problem. This is just for your reference. So I will upload an assignment on this soon. In the next video, we will look into indexing of direction. So see you in the next video.